This is OwlUp, where learning happens in minutes, not hours. For a deeper journey, explore all our courses at owlup.co. Now, let's dive in. Welcome back to Chapter 2 of our series, How AI Actually Works, The Complete Picture. In this episode titled, Machine Learning, How Computers Learn from Data, we're going to explore the fascinating process behind how machines can analyze data and improve their performance over time. So, if you've ever wondered how your favorite apps seem to get smarter with every update, you're in the right place. Let's dive in. Right now, as you listen, algorithms you've never met are quietly deciding which videos you see, which products pop up first, even which job ads reach you. Here's the twist. No one explicitly told them how. They learned from oceans of data you helped create. In this episode, we'll zoom in on the workhorse behind most of those decisions: supervised machine learning. Think of it as the quiet engine inside spam filters, medical image readers, language tools, and credit scoring systems. In industry, this style of ML is estimated to power the majority of commercial deployments, precisely because it turns historical examples into remarkably accurate predictions about what happens next. Instead of experts encoding every rule for "this email is spam" or "this image is a tumor," systems train on vast collections of labeled examples and learn to spot patterns too subtle or tangled for humans to write down. That's how image classifiers went from fumbling over basic objects to beating average human accuracy on massive benchmarks, and how companies like Amazon can surface items you didn't know you wanted, but end up buying anyway. Instead of living only in research labs, these systems now sit in everyday pipelines that quietly move money, content, and decisions. Banks lean on them to estimate who might default on a loan. Hospitals use them to flag scans that need a closer look. Streaming platforms rely on them to decide which new show to push into your feed. What changed is less the basic idea and more the scale. Millions of examples, cheaper compute, and better training tricks. That combination turned interesting demo models into infrastructure, reshaping how organizations decide, prioritize, and allocate attention. To see what's actually happening under the hood, it helps to follow one model through its career. Step 1. Someone has to decide what to predict and how to measure success. Is the goal to catch 99% of fraudulent transactions, even if a few innocent ones get flagged? Or to minimize false alarms so real customers aren't annoyed? That choice becomes a loss function, a numerical penalty the model earns every time it guesses badly in training. Different goals, different penalties, different behavior. Next comes features, the pieces of input the model is allowed to look at. A credit model might see income, repayment history, and existing debt. It probably shouldn't see race or zip code, even if those correlate with risk, because that can encode discrimination. Feature choices quietly bake in values, constraints, and sometimes bias before a single line of code runs. During training, the system doesn't just get better in some vague way. Every pass through the dataset nudges millions or billions of internal weights via optimization methods like gradient descent, hunting for a configuration that drives the loss down. When that process scales to massive image or language collections, you get landmark results: human-level vision benchmarks, fluent translation, recommendation engines that meaningfully shift a company's revenue mix. The real test, though, is generalization, how the model behaves on cases it has never seen. Overfit it to last year's fraud tricks, and criminals will slide right past tomorrow. Underfit it, and you miss obvious patterns. Teams juggle data splits, regularization techniques, and validation metrics to keep the system from simply memorizing history. Then there's drift. People change, markets move, attackers adapt. A hiring model trained on pre-remote work resumes may degrade as career paths evolve. That's why many commercial ML systems are retrained on fresh data, monitored in production, and sometimes rolled back when performance, or fairness, goes sideways. Underneath the hype, This is what everyday ML really looks like. Careful choices about objectives and inputs, heavy math and engineering to fit models at scale, and ongoing negotiation between accuracy, cost, ethics, and robustness in the messy conditions of the real world. Think about where this shows up in places you don't usually question. In a hospital, one system might score which X-rays deserve a radiologist's attention first, while another estimates the chance a treatment will work for this specific patient. Same training recipe, totally different stakes, constraints, and acceptable error trade-offs. Or take cities. Transit planners can train models to forecast rush hour congestion street by street, then simulate how changing one bus route or adding a bike lane might ripple through travel times next month, not just tomorrow morning. One analogy to keep in mind, like a chef running tiny A/B tests in a kitchen, product teams constantly tweak model objectives and inputs, then watch what happens to click-throughs, cancellations, or defaults. The best model isn't the cleverest mathematically, it's the one whose behavior lines up with what the organization actually values when things get noisy, political, and real. Machine learning is creeping into decisions that once lived only in human meetings and gut feelings. A loan officer's hunch, a doctor's "I've seen this before," a dispatcher's sense of traffic can all be augmented or quietly overridden by models. That shift raises fresh questions. Who's accountable when an automated choice backfires? How do we detect silent bias at scale? And what skills will matter when judgment is increasingly shared with software? As ML seeps into routine tools, it starts to feel less like magic and more like plumbing, invisible until it leaks. The next frontier isn't just squeezing out extra accuracy, it's deciding where we're willing to delegate judgment. Your challenge this week: anytime a system ranks or sorts something in your life, ask what quiet objective it might be optimizing. This was OwlUp, your daily step forward. To keep learning with structured courses and more insights, go to owlup.co. Until tomorrow.